Here we're going to use differentiation rules to find the derivatives of these three functions. We start out with 2x to the fifth minus 8x plus 3. Well, remember that's the same thing as 8x to the first power, and so when we differentiate, we'll use the power rule along with the constant multiple rule. We'll bring the 5 down and multiply. That'll be 10. Reduce the power by 1. 5 minus 1 is 4. Do the same thing to the next term. Bring the 1 down and multiply. That'll be minus 8. X to the 0 power after we subtract 1 from the power. And remember that the derivative of a constant is 0. Now, the way we usually interpret x to the 0 is as 1. And so that's negative 8 times 1, or just negative 8. Now, part B needs to be rewritten before we can apply the power rule. I'm going to rewrite that as 6 times x to the 1/3. The cube root of anything is that same thing raised to the third power. So this tells us that g prime of x is going to be 6 times 1/3. 6 times 1/3 is 2. Subtract 1 from 1/3 and you're going to get negative 2/3. I'm going to rewrite that with a positive exponent, so that would be 2 over x to the 2/3. And finally, we have h of x equals 5 over 7x to the 10th. So that also needs to be rewritten, and you need to be careful about how you rewrite it. I'm going to rewrite it as 5/7 x to the minus 10. The power of 10 does not apply to the 7. It's going to stay down where it was. So h prime will then be 5/7 times negative 10. I believe that's negative 50/7. Then we'll have x to the negative 10 minus 1. That's negative 11 power. And again, I'm going to rewrite this so that the exponent is not negative. Now we're going to differentiate three more functions. Here we have 3 over the fifth power of 2 to the x. There are lots of different ways you could use to differentiate this. You could use the quotient rule, you could use the power rule, you could use the chain rule. I think I'm going to use the chain rule. I'm going to rewrite this as 3 times 2x to the minus 5. The other ways are perfectly fine. I just thought I would use the chain rule because it might be, while it might not be the easiest, I think it's the most versatile method. All right. Plus, I think it'd be good for you to see this using the chain rule. So what I'm going to do is, I'm thinking of this as an inside function and an outside function. The inside function is 2x, and then the outside function is 3 times that 2x to the minus 5. So I'm going to concentrate on the outside function. We've got 3 times something to the negative 5 power. I'm going to bring that negative 5 down and multiply it by the 3. That's going to give me negative 15 times 2x to the negative 6 power. And then I need to multiply by the derivative of the inside function, which is 2. And I'm going to simplify that. That's 2 to the 6th times x to the 6th in the denominator, and you'll have a 2 in the numerator to the first power. One of those powers can be canceled, and so I'll have minus 15, 2 to the 5th, x to the 6th. Minus 15 over 2 to the 5th, x to the 6th. Again, there are other ways you could have done that. You could have differentiated this. You could have multiplied this out first. You'd have 2 to the 5th, x to the 5th, so that you'd have 32 x to the 5th. This is actually minus 15 over 32 x to the 6th. Anyway, let's continue. In part E, we have y equals 3 sine x. The derivative is just going to be 3 cosine x. The constant multiple rule, if you have a constant times a function, the derivative is the constant times the derivative of the function. So we basically just bring the 3 along and differentiate the sine of x to get cosine of x. F has a little bit of a trick in it, or rather it was meant to trick those of you who were maybe not paying as close attention as you could have. If you thought, I'll differentiate this and get 2 times pi, remember that pi is a constant. Therefore, pi squared is a constant. The derivative of any constant is 0. The derivative of pi squared is 0. Then we'll have the constant multiple rule. We have negative 5 times the derivative of cosine x, which is negative sine x. And that turns out to be just 5 sine x.